Okay guys, so today, remember how last unit we had gotten a problem where the answer came out to x equals the square root of -4? Do you guys remember seeing that? It came out to square root of a negative, and we before had said that there are no real solutions. You guys remember? So we just got to stop. Today, there were no real solutions, meaning real numbers. So today we're going to be working with something called imaginary numbers that helps us get answers for when we have the square root of a negative. So now the square root of a negative is something we actually can do, but because that's not considered a real number, we call it an imaginary number. Okay? So what we need to know for imaginary numbers: when we have negative square roots, we have the letter I, which represents the imaginary number, and that letter I is equal to the square root of -1. So now anytime we see square root of -1, we just replace it with the letter I. Okay? So that means that I squared is equal to -1, which is something we have to have memorized. Okay, so now the rest is all just examples for us. That's all we need to know. So example 1, square root of -81. Now for this one, I'm going to write it all out first. So the square root of -81 is the same as the square root of -1 times 81. Do you guys agree with that? -1 times 81 is how I got the -81. And the nice thing about square roots is we can actually break this up. So this is the same as the square root of -1 times the square root of +81. So we would end up getting the same thing either way. But the reason why I like to write it out this way is because we know what the square root of -1 is. I just told you. The square root of -1 is equal to I. So we just replace it with I. Okay. And the square root of 81 is what? 9. So my answer is 9I. And that's your answer. So I just took the negative out right here, and the reason why I do that just for this problem is to show you that when we have a negative number on the inside, we can separate that -1 and then just work with the positive number. So anytime you see a negative inside the root, you can automatically take out the negative and just write I. Okay? You don't have to write it out this many steps each time. I just want to show it to you the very first time. Okay? So let's look at example 2. And that's basically all that we're going to be doing for the rest of the notes. Now the thing about I is it works very similarly to a variable, but it actually represents square root of -1, but it kind of acts as if it was a variable. Okay? So when we had something that looked like this, 3i, all of that to the second power, what did I do with this exponent? Distribute it. So let's distribute the exponent. That gives me 3 to the second power times I to the second power. What's 3 to the second power? 9. And I already told you, we wrote it up at the very top. What is I to the second power equal to? -1. So now that we have I squared, I can just change it to a -1. So what's 9 times -1? -9. And that's your answer. Okay? So I squared is actually really, really nice. Whenever we get an I squared, we automatically just change it to a -1. The reason why I squared is -1 is because that comes out to I squared is equal to square root -1 times square root -1, right? That's I times I. And remember what I told you? Those square roots cancel each other out, so it comes out to just what's on the inside, which is -1. So that's how I squared equals -1. Anytime you see an I squared, just automatically replace it with -1. It's just substituting back in. Make sense? Kind of? Let's try another one. Example 3. 8i times 3i. So similarly to if we were working with variables, we multiply the coefficients. 8 times 3 gives me 24. And I times I gives me I squared. Now, you never, ever, ever want to leave I squared in your answer because we can actually replace that with a number. So this is 24 times negative 1, so my answer comes out to negative 24. So you should never have I squared in your answer. You should always replace I squared with negative 1. Question so far? Okay, example 4. Root negative 5 times root negative 20. Before we start working with i's and these negatives, I always suggest that we multiply first. So this is the same as the square root of negative 5 times negative 20. And that's kind of going to work out in our favor, right? What's negative 5 times negative 20? Positive 100. And can we take the square root of positive 100? Yeah, what does it come out to? 10. And you're done. Okay, example 5. So we have 4 square root negative 36. So what we want to do here is bring the 4 down. We're multiplying whatever comes out of that by 4. Because I have a negative inside the square root, I can automatically write I. So I know there's going to be an I somewhere in my answer. So we can take out that negative and change it, leave it as an I. And what's the square root of 36? 6. So this is the same as 4 times 6i, which we can simplify to 24i. Root negative 15. So example 6. Okay, so I see a big no-no. What do you guys see? So how do I get rid of that? We need to multiply top and bottom by the square root of negative 15. And that's going to give me on top the square root. 60 times negative 15 gives me negative 900. All over. Okay, now really quickly, if I give you square root 3 times square root 3, what does my answer come out to? 3. If I give you root 10 times root 10, what does my answer come out to? 10. If I give you root x times root x, what does my answer come out to? X. So if I give you root 15 times root 15, root negative 15 times root negative 15, what would my answer come out to? Negative 15. So the square roots end up canceling each other out. Okay? Alright. So let's simplify the top. If I have square root of a negative 900, that negative automatically tells me that my answer is going to have what in it? I. And the square root of 900 is 30. So this is 30i over negative 15. And does that reduce at all? It does. Negative 15 goes into 30 2 times. So that's negative 2i. Okay, example 7. 18 over 2i root 6. Okay, so remember how I told you guys yesterday that a root is not allowed in the denominator? If I is equal to the square root of -1, do you think I is ever allowed in the denominator? No. So sometimes we might see just an I in the denominator, and that's also not allowed. So now we have two things that are never allowed in the denominator. So will you write a note? I cannot be in the denominator. Okay? So two things that are never allowed in the denominator, roots and I. Okay? So I see two things in this denominator that are not allowed. I see an I and I see a root 6. So we're going to rationalize it just like we did yesterday. So I multiplied top and bottom by 2I root 6. Well, because everything is multiplication, there's no conjugate. It's only when there's an addition and subtraction in between. Since this is all multiplication, we can just multiply by the exact same thing. Okay, so conjugate is only if there's something being added or subtracted. So let's look at the top first. 18 times 2I root 6. 18 times 2 gives me 36, so that gives me 36I root 6. We are allowed to multiply whatever we want. Now let's look down here. 2I root 6 times 2I root 6. 2 times 2 gives me 4 times I squared. That's something that I see a lot of students forgetting. I times I gives I squared. It doesn't just say I. You're multiplying them together. And then root 6 times root 6 gives me 6. Okay, let's simplify a little bit. This is 36I root 6 over 4 times 6, which gives me 24. And then what do you guys remember about I squared? It's equal to -1. So -1 times 24 gives me -24. So we just multiplied all three of these things together. Can I reduce it all?
Yes.
6 goes into both of these. Anything bigger? 12. 12 goes into 36 3 times, and 12 goes into -24 twice. So that gives me an answer of -3I root 6 on top, all over 2. Alright, we're going to do examples 8 and 9 together because they kind of correspond. So write both of them down. 8, we have the square root of -17 squared. And 9, we have the square root of -17, all of that squared. So we have two different ways of writing this, but our answers are going to come out different. So I just want to show you the difference. Okay, so looking at example 8, let's actually expand this out. Is the whole thing being squared, or just the -17 being squared? Just the -17. So this is the square root of -17 times -17. What's -17 times -17? 289. Positive 289. And what's the square root of positive 289? Positive 17. So if the inside is being squared, our answer is going to come out positive. What happens if the whole thing is being squared? This is the same as what? Root -17 times root -17. Now, because technically a square root is an exponent to the 1/2, which we will get to and learn about some more. I want to say, can't remember the exact unit, but we will work with this. These two are actually the same thing. Order of operations tells us we have to take care of the exponents first, which means I have to take care of these square roots. So I'm canceling each one out. Okay? So square root of negative 17 times square root of negative 17 gives me negative 17. Okay? Make sense? Yeah? Okay, so if you're squaring the whole thing, the answer is just what's on the inside. If you're squaring the inside, your answer should come out to be positive. Okay, so there is a difference between these two and what it is they're asking us to do. Okay, last one, example 10. Root negative 3 plus root negative 27. Okay, neither one of these are perfect squares, right? But this root negative 3 has a negative, so I can at least rewrite it as I root 3. So I can take out that negative and rewrite it as I. Plus, are there any squares inside of negative 27? Well, 27 is the same as what? 9 times 3, which is 3 to the third power. So are there any pairs in there?
2.
Yeah, 2 3s. So this is going to be 3i because of that negative. And what's left over inside the square root? There's still 1 3 left over. So this is what I mean by square roots kind of behave as like terms. I have one I root 3 and 3 I root 3s. So how many I root 3s do I have? 4. So we can just add them like they are like terms, and we get 4I root 3. So if there's an I attached, both of them must have the I, and the square root must be exactly the same as on the inside. So if they're not exactly the same, for example, if I have I root 5 plus I root 7, these are not the same, right? So I have to leave them separate. Since these are the same, I can combine them. Okay? So only if the roots are the same are you allowed to combine.